This is a question number 10 from thermodynamics section of KROTOV, and let's start with the solution of this question. So let's understand what does the question say. A vertical cylinder of cross-sectional area S contains 1 mole of an ideal monoatomic gas under a piston of mass m. So here we don't have a negligible mass piston, we have a piston having mass m. Now, at a certain instant, a heater which transmits a gas at an amount of heat Q per unit time is switched on under the piston. Okay. Determine the established velocity V of the piston under the condition that the gas pressure under the piston is constant and equal to P naught, and the gas under the piston is thermally insulated. So let's start with the figure. Alright. I assume this to be the cylinder. Okay. Diagram is not up to the scale. Alright. So that is acceptable. And here we have a piston having mass m. Now, the pressure of the gas is assumed to be P. I think this question is wrong somewhere. While I was solving, if I assume this to be P and external pressure is P naught, then answer is matching. So P external is P naught. Alright. And the pressure inside of the gas, I'm assuming this to be P. So at every point, what we can say that, this is, so I'm sorry. What we assume here is that this piston is moving at constant velocity. That means acceleration of this piston is 0. So we can clearly say that at every point, the force from inside has to be equal to the force from outside, right? So pressure inside has to be pressure equals to outside. So pressure outside is equals to P naught plus mg by S. That has to be equals to the pressure of the gas inside. This is the very important equation. Alright. The second thing, what we have said is that inside this cylinder there is a source of heat. Alright, that is releasing an amount of Q joules per second. So let's assume for a dt time the heat given by this source is Q into dt. Alright, and that dt will actually bring a change in internal energy as well as change in work done. So what will be the change in internal energy? Change in internal energy will be N CV that is equals to 3 by 2 R into dt plus P external, this P external, that is going to be P naught plus mg by S into dV. Now I'm writing it directly. P external, that is P naught plus mg by S, is equals to P. So we can write this P into dV. Alright. Now here what you need to understand, this nr dt. Okay, just exclude this 3 by 2 term. So nr dt is again P dV into 3 by 2 plus P dV. So this will come out to be as 5 by 2 into P dV is equals to Q dt. Now what is the change in dV? If I assume this whole height to be h, and so if there is a slight displacement of the piston, the change in volume will be area of this piston, that is, I think that is given S. Alright, we don't take it as A, we'll take it as S. I'm ignoring this. Okay, S into dH, that is equals to 5 by 2 into P into S into dH. This is Q dt. Now assume this, that Q is constant. It is being given that heat Q per unit time. So this is a constant quantity. It is independent of time. So if we differentiate both sides with respect to t, we are left with Q equals to 5 by 2 P into S into dH by dt, and we are concerned with the value of dH by dt only, that is the velocity of the piston. So we take it as V. Okay. Now, so V is equals to 2 by 5 into Q by PS into Q by PS. This is the velocity that has been acquired by the piston. Alright. Thank you. I hope this solution helped you guys.